Hi everyone, I'm Ms. Milkowski, the mathematician, and today we are going to do a problem about circles and tangents and angles and arcs. It's a big problem. So let's take a look. We've got ray BC and ray BA, and we know they are tangent to circle D. Find the measure of angle ADC and the measure of arc AC. First thing we want to do is mark off what we want to solve for, okay? The problem's telling us we want this angle ADC, so we're just going to mark that off in green. And it says we want the measure of arc AC, which is right here, okay? Oops, I hope you can see that, hopefully. It's red right there, okay? So the reason you need to do that is because then you know kind of what you're going for, because when you look at a figure in a picture, you will be able to say, okay, is what I'm doing going to get me closer to what I want? And if you're kind of just still looking at the picture, you're like, well, I don't really know what I should be doing, right? So mark everything off. We want the measure of that angle, and we want the measure of that arc. Okay, so first thing is usually in a problem, they give you information that's going to help you. Sometimes there is superfluous information that can happen, but a lot of the times there isn't. So you always check everything anyways, because it might very well help you. So if we know that BC and BA are tangent to circle D, there's something important that we know about when a radius comes in and hits a tangent at the point of tangency. And what we know is that it creates a right angle, okay? So a radius is perpendicular to a tangent of a circle at the point of tangency. So when that radius comes in, boom, and it hits that point, because remember, tangent means that it only hits the circle at one point, okay? That radius comes into that one point and it forms a right angle, okay? And then the same thing happens on the other side. And this is super duper important, and I always tell my students, when you have a circle and you're told you have a tangent, immediately draw on a radius and mark that angle off as 90. It may not help you, that's true, but it also might help you. So there's no harm in doing it because it's super quick and it could lead you somewhere that could, lead you to another step that could then solve the problem, right? So there's no harm in doing it. So anytime you see a tangent, draw on a radius, boom, mark the angle that it forms as 90. Okay, so now that we have that, what I want you to think about is we know the measure of this and we want the measure of that. And if you think about it, we have a quadrilateral here. Boom. So what if I were to pull that out so we can see it better? Because I always say, if you can pull out a quadrilateral and kind of draw it and take away all the things that, look a little confusing. There's a lot going on there. And just mark what you have. Okay, so we've got 37, this is 90, and this is 90, okay? And remember, this is the angle we want to solve for. So all I did was I pulled this quadrilateral out down here. Okay, so we'll call this X. Okay, this is the angle I want to solve for, angle ADC, okay? Well, if I have a quadrilateral, what do I know? I should probably put degrees on these 90s, okay? If I have a quadrilateral, what do I know about the sum of the measures of the interior angles? I know that the sum of the measures of the interior angles of a quadrilateral is 360 degrees. So I can just write a super duper simple equation and say, well, okay, 37 plus 90 plus 90, okay, 37 plus 90 plus 90 plus X, okay, is going to equal 360. Boom. Now is it super easy to solve for X? Absolutely, okay? So I'm going to do this in kind of an interesting way because I'm not using a calculator. So I'm going to say that it's 37 plus 180, and you're going to see why. And again, you have your own way, okay, that you solve. I am not going to tell you you need to do it one way or another way. If you want to use a calculator, you go for it. Okay, so then I combine these two because 180 is super easy to subtract from 360 because we know that it's half. Okay, so I subtract 180 from both sides. I end up with 37 plus X equals 180. Okay, then I just subtract 37 from both sides. Okay, so in my head, if you want to know what I'm doing in my head to get this, I say, well, what if I subtracted 40? And that would bring me to 140, but then I only subtracted 37, so really I need to add 3 back in, so that's going to be 143 degrees. Boom. Okay, so X equals 143 degrees, so I can write that right here, 143 degrees. Okay, so now it didn't ask for X, remember it asked for a specific angle, so I'm just going to come up here and rewrite it. The measure of angle ADC is 143 degrees. Okay. Boom. Now I want the measure of arc. The measure of arc AC, okay? So if I know the central angle is 143, what's the measure of the arc, okay? So the measure of the arc that the central angle intercepts is the same, okay? It has the same degree measure, okay? So if I come over here, I'm just going to say that the measure of arc AC is 143 degrees, okay? And that really is the answer, because the central angle and the arc it intercepts, and its intercepted arc, okay, have the same degree measure. Remember, this is the measure of the arc, not the length of the arc. The length of the arc is something different. But the measure of the arc, once you know the central angle, you know the measure of that arc is going to be the same, okay? The degree measure of that arc is going to be the same. So this is 143, the arc is 143. If this were 100, the IAC would be 100. If this were 120, this would be 120, okay? Perfect. Now, something that some students sometimes memorize is that there was a super fast way to solve this problem, and that was that these two angles, okay, sum to 180, okay? They're supplementary. So you can just say, well, I know that, 37 plus this angle equals 180, so you could have kind of done it, super fast on the side and just said, oh, well, maybe I'll do it in the green. 37 plus x equals 180, and then subtract it and said, okay, subtract 37 from both sides and say, okay, x equals 143. And that's perfectly fine, but you're memorizing. You know what I mean? You are. And what if you forgot that they were supplementary and you confused it and thought they were complementary and summed to 90, right? That could be a problem because you get the problem wrong. So that's why we ask why. Why are they supplementary? Well, they're supplementary because you end up with these two 90-degree angles, okay, from drawing in this radius and drawing in that radius, okay? And then because the whole thing sums to 360, 180 gets knocked out by the two right angles, so you only have 180 left, okay? So that's where it's coming from, okay? So if you memorize it, that's totally fine. It's just it can be a little dangerous. That's what I always say. It can be a little dangerous to memorize. So it's good to understand where it's coming from, why that happened, okay? And that is because you create a quadrilateral with two right angles, okay? So because the whole thing adds to 360, you do end up with 37 plus x equals 180, but it's because you subtracted out the two 90s that are formed, okay? And that'll happen every time. Every time you draw a radius to a point of tangency, you're going to create that right angle. So there you go. Hey everyone, I'm Ms. Milkowski, the mathematician, and I hope you found that last video helpful. If you have any questions or if there are any topics you'd like to see me cover in future videos, definitely let me know in the comments below. Thank you again for watching. I hope you have a wonderful day, and I'm going to leave you with the most important piece of advice I can give you, which is when you're doing mathematics, always ask why.